Now let's talk about another kind of hazard, pipeline hazard, which is a control hazard, which is more complicated than data hazard. Okay. So what this control hazard is? If you if we review the branch instruction data path, it kind of look like this. Like this is we are reviewing your BNE or B equal data path, right? So what we are doing there is basically if my condition is met, then my target next instruction address would be this current PC value plus 1 plus sign extension of immediate. Okay, so that's your branch instruction, BNE L1 or B equal L1, that kind of instruction are ultimately converted into machine code. And then processor will basically make a subtraction between RS and RT, that content, and see if the logic zero flag become 1 or 0. So depending on that, it can determine, controller can determine that if both the contents are equal or not, and depending on your BNE or B equal instruction, it will update the PC accordingly. Either it will go with PC plus 1 next instruction, or PC plus 1 plus sign extension immediate. So these two condition is called, like in a formal term, is called a branch is taken or not taken. Okay. So let's say we have a assembly call like B equal R1, R2, L1. So from that point, it has two way to go, right? Either next instruction will be your next instruction of BEQ, or it can be the L1 instruction at the level 1, right? L1. So branch taken means if the condition is met and we jump to the target level. That's the branch taken path. And branch not taken is that is your branch condition is not met, so you fall through the next instruction, which is at PC plus 1. That is branch not taken means. Now let's look at this three line code. So label L, you're adding R1, R2, R3. Then you are checking BNE, R1 and R2, and if they are not equal, then jump to level L, or that if the branch taken, then you go to level L. If branch is not taken, you fall through the next instruction, which is sub R5, R1, R3. Okay. Now look at the pipeline execution here. Let's analyze it very in detail. So we are executing this first one, fine. That's my data producer. And your BNE is data consumer, which is produced from instruction 1 at level L. And you are basically subtracting values R4 and R1 from R4 and trying to make a decision that what my program counter would be. Okay. So this one, if the branch is taken or not taken, cannot be concluded till the exe stage is done for instruction 2. Okay. And also in turns, like we cannot, how do I say? There is a problem that we are producing the data at R1. It is kind of similar to data hazard here in this situation. And we are consuming the data at R1, which will be at the write back stage. Of course, now we can actually, in this case, we can data forward it. Okay, 4 nanosecond, the data is ready, updated value is ready, and I can consume it here, right? And then what happens is here, the third instructions is instruction phase had to be done in the between 3 nanosecond and 4 nanosecond, right? So we had a data hazard, we resolved it through the data forwarding, that's okay. Now the question is this: which instructions should I fetch? Because at this point, if the branch is taken, my next instruction fetch would be from L1, from L. If branch is not taken, then my instruction fetch will be from your subtraction. So at this point, that means processor need to know if it is branch taken or not taken. If it is a branch taken, then it will be fetching for L1 that address. Sorry, L. Why I'm keeping telling L1? It is L. From the label L, whatever that address of instruction 1, it will fetch from there. And if branch is not taken, it should fetch from address of the instruction 3. Now, branch is taken and not taken is not determined till the end of the execution cycle of the BNE, which is at the 5th nanosecond, right? But we are trying to start the fetch at the 3rd nanosecond. So we don't know. So at this point, we clearly don't know if the branch is taken or not taken, right? Of course, one would be like, okay, you put a stall for 1 clock cycle, all right, and then you decide, I think 1 clock cycle exe, and maybe you need 2 clock cycle. Basically, you need to make sure you can start only if you know that what is the result out of the exe. So exe is completing at 5th nanosecond, okay. Only then you can start the instruction fetch for the 3rd instruction if you were to go with the stall. So I think this is a typo. Please note, it is stall for the pipeline for the 2 cycle, okay, not 1 cycle. 2 cycle you need to stall before you can actually determine branch is taken or not taken. Now that means this branching and looping, these are all very common in the code. It occurs, right? And we cannot do anything like data forward or anything like that at this point for this branch taken not taken scenario. So it's to make a clean solution, okay, we really need to stall the pipeline for at least 2 clock cycle, and before we can actually check like what is going to happen. So here, but that means it is surely going to slow down the pipeline performances, and we won't get much benefit as we want to get from a pipeline architecture.